Okay, we're going to start a series of solving linear equations, and I just wanted to show you IXL underneath Algebra 1. Essentially, we're going to pre-test on this section here, I1 through J10. We're not going to worry about J2 at all. We're going to pre-test, and then based on that, we'll decide where you need to go. This I section is some pre-work. Okay, so we're definitely going to pre-test on that section. You may not have to do that whole section, so make sure that you do the pre-test. And then we'll pick and choose individually like where you need to start on IXL, okay? Remember the standards that you individually need to do. You want 10 problems on that particular standard at an 80%. If you don't make the 80% after 10 problems, then you need to keep going. Okay, now if you get up into like the 30s and 40s doing problems, then you need to come see me. Okay, if you keep getting them wrong or you've done so many problems that it's going to be really difficult to get an 80%, you need to come see me and we need to figure out another alternative, if you will. Okay, first of all, let's look at like terms because we can combine like terms, and we've been doing that if you had used the tiles with me earlier. So let's just kind of go through and we're going to circle like terms. Like terms, first of all, by definition, is we're looking for the same variable and the same exponent, or not exponent, exponent. Okay, so both of those have to be true for them to be alike. So some that are alike, go ahead and see if you can pick them out. So for instance, 7x. Let me circle it so you can still see it. 7x and 2x and any more? Those are like terms. Okay, let's pick out some more. Are there any other things that would go together? We got a 2a and 2a perhaps. Any more a's? There's another a. All right, and that looks like it, right? Now, I do want to mention that if there's no exponent explicitly written on that variable, there's actually understood to be like a little 1 up there. We just don't write it, okay? And also, the coefficient is this number that's in front of the variable. So 1 is a coefficient, even though it's not, it's understood to be there. 7 is a coefficient. 2 is a coefficient. 4 is a coefficient. 6 is a coefficient. It's the number being multiplied to that particular variable. Okay, so let's go ahead and combine like terms. We have look at the green ones, 2a and 1a, right? Is how many a's? Well, that's 3 a's, right? And then let's look at the pink ones. Make sure I get this, try to get the same color here. 2x and a 7x. How many x's is that? 9 plus 1 more. And that's all that you could do there. That's combining like terms. All right, we're going to solve one-step equations. And some of us have been using algebra tiles, so I do want to respect you in that manner, and I want to show you and work with those tiles as well. And you can come get some off my desk if you need that visual and hands-on. But I'm going to try to demonstrate it both ways. If you don't need the tiles, then don't use them, okay? If you need them, use them. All right, so we want to, first of all, we want to get rid of any plus signs or subtraction signs that are being done to x. So if I read this, x plus 4 equals 7, okay? What's being done to x? We're adding 4, right? So we're going to undo adding 4. So I'm going to think about subtracting 4, or I'm adding negative 4 to that. If we're doing our tiles, I'm adding negative 4. And I'm going to use red to represent negative because I don't know if I can get, well, maybe I can write that in there. So these are negative. So I'm going to use red as negative. Your tiles, the color didn't really make any difference. If I do it to one side, then obviously you have to do it to the other, right? 1, 2, 3, 4. So all these red ones are supposed to be negative. I'm having a hard time writing that in there with this particular pen. All right, and then we want to take away any zeros. So 4 plus a negative 4, that zeroes out, right? That makes 0, so we get x left equals 7 plus a negative 4, 3. Now if you're using tiles, again, we're looking for these zeros, right? So this gets knocked out. That makes 0, that makes 0, this makes 0, that makes 0. I take those away. All right, here's another one-stepper. Again, we're going to need to get rid of any of these ones. We're going to get rid of that, okay? So if you look at the equation, x minus 2 equals 8. So hopefully you can see how the tiles represent that if you're using tiles. So we're going to undo this subtraction. So how do we undo minus 2? We would undo it by adding 2. Showing that in our tiles. So I'm adding, those are positive ones, okay? Remember, whatever you do to one side, you've got to do to the other side to keep it balanced. Remember the old time, well, you may not. You're going to have to ask Miss Underwood, but a long time ago, like the old scales, I'm going to have to find a picture of it. An old scale, you want to keep it balanced. If you take something away on one side, you have to take it away on the other side. If you add something to one side, you got to do it to the other. And that continues. Now we look for zeros. So if I look at the left-hand side of the equal sign, do I get any zeros? Negative 2 plus 2, zeros out. So we have x left. Not quite sure why I'm using red. Let's try blue. The red's hard on the eyes, isn't it? X plus 0 equals 8 plus 10. Look over here. These zero out, right? We said those are gone. 8 plus 2. Does anything zero out over here on the right-hand side? No. How many ones do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. We got 10. And hey, guess what? 8 plus 2 is 10. How about that? All right, so we're going to do one more. What if the one-stepper is no longer adding and subtracting? What if it's a multiplication or a division? If it's a 3x, there's understood to be a little multiplication in there. That's 3 times x if we read that. How do you undo multiplication? You divide. So we're going to divide by 3. So x should equal 4. If you're using tiles, okay, you're going to arrange them, arrange the ones so that they're grouped together. So I kind of already did that when I set it up. So if you look at, if you were to make some groups, okay, we're reconnected. So 3 times x, how do we undo multiplication? And you'll notice as well, and somebody's going to ask this, well, how come you're not adding 3 or subtracting 3? Look over here on your tiles. There's no ones being done to x, with x. Like you have no 1 tiles over here on the left-hand side. So that's why we're not adding or subtracting ones. Okay, so we're going to undo this multiplication by division. If you're looking at your tiles, you want to group them into 3 groups. So 3 even groups. So 1x gets 4, this one. You think with the tiles, if 3x equals 12, then how many ones are in each group? There's 4 ones in each group. Okay?